SCAG stands for the South Coast Affinity Group. It's an innovative waste contract with an emphasis put on recycling.
The members of SCAG are the University of Winchester, Southampton Solent, University of Portsmouth, University of Southampton, Bournemouth University and the Arts University Bournemouth.
My name is Louise Wigglesworth. I'm the Assistant Facilities Manager for Contracts in the Estates and I work at Bournemouth University.
I'm Neil Smith. I'm the Environment Manager at the University of Southampton.
My name is Matt Jane. I'm the Energy and Environment Manager at the University of Winchester.
Hello, my name's Ian McCormack. I'm the Energy and Environmental Manager for the University of Portsmouth.
The South Coast Affinity Group, or SCAG, was formed in 2008 to develop a shared recycling contract based on improving waste management, increasing recycling and saving money. The group brings together experts in procurement, waste operations and environment management. This is one of its strengths and means economic, environmental and social benefits can all be realised.
I think the lessons that other organisations can learn are sharing experience when all the universities get around the table that are part of the contract, and we have a cross-section of skills at that table from staff with specialisms in procurement and waste management experience and just general environmental experience. So we're all sharing our years of experience we've had in the sector.
The SCAG partnership is just that. It's a partnership between the waste contractor BIFA and all the universities in the consortium. We've really worked together over the last 5 years to significantly improve the performance of the contract.
Since 2009, 5,000 tonnes of waste has been collected from the South Coast universities each academic year. More than half of this total waste was taken to landfill. However, since the introduction of the SCAG consortium, the management of recycling and landfill collection schemes is far greater. The 5-year contract was awarded to BIFA and started in January 2009. It was extended for 2 years based on the excellent performance of the contractor. The group meet regularly with BIFA to review operational matters and discuss how well the contract is working. Most waste items produced by the universities can be recycled and are collected in one of the many bins available on site. All recyclables are collected and transferred to the Material Recycling Facility, or MRF. The recycling contract includes pay-by-weight facilities. The electronically chipped bins are weighed and recorded by the waste lorries. This provides accurate data on the cost and amount of waste produced. The information is invaluable as it helps to improve recycling. Materials are loaded to start the process. A conveyor belt transfers the recyclables to the first pre-sort cabin. Manual pickers target film, rigid plastic and non-recyclable items such as textiles. Covered materials are stored in bays below the cabin. The OCC screen separates the materials. Cardboard rolls over the top of the discs and continues into an OCC storage bay. Glass passes through the OCC screen to a glass screen underneath. This smashes the glass into smaller pieces. All other recyclable materials are separated at this point. Glass continues through the process and onto a vibrating glass table, which separates the glass into different size fragments. The new screen removes larger paper, such as newspaper. Contaminants are again removed by pickers before entering the storage bunker. Small fibre items ride over the top of the polishing screen. Pickers remove contaminants before the items enter a mixed fibre storage bay. Heavier items fall down to the bottom of the polishing screen to continue along the line. At this point, all fibre and glass is removed. Only plastics, steel cans and aluminium are left. Steel cans are removed by a magnet and stored into a bunker. An eddy current or reverse current is used to separate the aluminium, which flies over the magnet and into a storage bunker. This leaves the remaining mixed plastics and a small amount of non-recyclables behind. An optical multi-sort uses infrared sensors to detect specific polymers within a mixed stream of material. It incorporates precision air rejectors to accurately sort selected polymers. HDPE milk bottles and PET clear bottles are separated before being checked one final time by a picker. Once every material has been separated, the items are compressed and baled. These bales are then transported into specific trucks for resale. These bales can be reprocessed in order to create a variety of new products. All of the residual waste destined for landfill is now sent for incineration with energy recovery. in order to generate power from the national grid. This means that zero waste to landfill has been achieved.
In the last 5 years, SCAG members as a group have saved over £800,000 by sending waste for recycling rather than sending it to landfill.
As a partnership, we've been really successful in driving our recycling rates up, and that's been a fantastic achievement of this partnership.
As you can see here, in 2009 the universities in the SCAG group were only recycling 30%, but as of 2013 this had increased to 65%.
So now we must make sure that we don't slip backwards and consolidate what we've achieved, and that will require us to continue to engage and educate our staff and students to ensure they play their part in our recycling success.